This is the electromagnetic spectrum. In this spectrum line, the frequency increases as we go from left to right. We can see that the frequency of FM is less than the frequency of microwave.
This is the block diagram FM radio receiver. Signal from air comes to antenna and is passed through a pre-select filter which just takes FM spectrum out of the air and sends it to the low noise amplifier. Low noise amplifier amplifies signals and then signal is passed to mixer. Mixer takes sum and difference of two input signals. Two input signals are from oscillator and amplifier. We can tune oscillator so that we can select a difference station.
Output of mixer is what we called an intermediate frequency, and then we filter the required frequency. Demode turns encoded information into audio. The audio then passes through the audio amplifier and then it passes through the speaker. This simple FM radio receiver circuit consists of 4 transistors, 2 inductors, a rheostat, couple of resistors and capacitors of different values, DC battery of 1.5 volt and a switch. These circuits also consist of a regenerative RF stage TR1 followed by a 2 of 3 stage audio amplifier TR2 to TR4. In some areas, 3 stages of audio amplification may not be necessary, in which case TR3 and its associated components can be omitted and the free end of capacitor C5 connected to the collector of TR2. The critical part of the FM radio receiver is the first stage, where the wiring must be kept as short as possible. Coil L1 is formed by winding 8 turns of 1 mm enameled copper wire on a 6 mm diameter former, which is then removed. After that, L1 should be stretched carefully and evenly to a length of about 13 mm. The tuning capacitor VC1 is one of the 2 FM sections of a miniature FM transistor radio with built-in trimmers VC2. The earthy end, which is moving vanes and spindle, is connected to the 22 picofarad capacitor C1. The value of the RF choke L2 is not critical. Anything from 1 microhenry to 10 microhenry being suitable. The output is suitable for ordinary earphones connected in series to provide an impedance of 64 ohm.
Now we are going to tune the receiver according to the required frequency. To operate the radio receiver, potentiometer VR1 must first be advanced slowly towards the end of the track connected to the battery positive until at about the halfway point a sudden slight increase in background noise will be heard, indicating the onset of oscillation. It then should be backed off very slowly until oscillation just stops. It then should be possible to tune in some stations. The correct frequency range of 87 MHz to 108 MHz can be obtained by adjusting VC2 at the high frequency 108 MHz and slightly stretching or squeezing together the turns of coil L1 at the end 87 MHz approximately. So we can see that in the circuit the components which are required to tune the radio receiver to the desired frequency is the VC2 capacitor and the L1 inductor.